So within the chordates, we have the smaller group of vertebrates. So these are going to be organisms that have a vertebrae or backbone. So typically this is going to enclose the spinal cord and take over the function of the notochord. So this is going to provide structural support to the back, to the spinal cord, to help protect it. And then it takes over these mechanical roles. So those are the roles of the muscles being able to attach to something. So a lot of like your spine is bone that your muscles attach to provide you with posture, to provide you with mobility. We also see the development of neural crest cells. So these are going to develop along the edge of the neural tube. So this is the ectoderm, that is the outer embryonic cell layer. And during development of chordates, it folds up into these two ridges, and then those two ridges kind of close together. And that creates what's called a neural tube. And that neural tube becomes the nerve cord and the brain. So all chordates have this neural tube. But what happens in vertebrates is we have these crest cells that are these green cells. And these develop kind of along the edges of the neural tube. And then those are going to disperse throughout the embryo. They actually give rise to the teeth as well as some functions of the skull. So these neural crest cells are actually going to break off and migrate throughout the embryo to become other structures. So now that we have a vertebra, which is a backbone, we are going to be able to build a skeletal system. We're going to start to see complex nervous systems. This development occurred during that Cambrian explosion, and this is going to make these organisms much more efficient at capturing food, because they're going to be able to start developing methods of swimming quickly to catch prey, as well as methods of swimming away from predators to avoid being eaten. So we have two groups of vertebrates that don't really have a true backbone. So here's my vertebra right here, and we're looking at Myxini and Petromyzontida. And together, these make a clade called cyclostoma. And cyclo means circle, and then stoma means mouth. So literally circle mouths. And that's because these guys do not have true jaws. So they do have some rudimentary vertebrae. So here we've got, this is a lamprey, and that is going to belong to Petromyzontida. So lampreys have what we consider rudimentary cartilage, so it's not quite ossified into bone, but there are segments of cartilage along that dorsal notochord that are kind of the beginnings of a vertebral column. We also have hagfish. And so this is a hagfish. Hagfish belong to this group up here, Myxini. And this prefix mix means slime. And hagfish are going to be extremely slimy. So they can produce buckets and buckets of slime. They basically secrete this water-absorbing substance, and as soon as it touches the water, it creates this slime. And they can make several liters per minute. And this is actually a defense mechanism. If something tries to swallow a hagfish, it's going to choke on slime before it actually is able to eat the hagfish. Most lampreys here are parasites, so they're going to use, so this is a lamprey jaw. They're going to use this to attach to a host, kind of like a parasite, and then they can scrape at it with these little keratin teeth. They're called horny teeth because they're made of keratin and not bone. And then they've got a little bit of a scraping radula here.